Hello class, today we are going to continue learning about winds. Feel free to follow along with this material on page 103 as well as 104 of your Pearson textbook. But before we get into today's concept, let's review what we learned about last time. Last time we learned about how winds are produced. Well, winds are produced because of a difference in air pressure, which is ultimately produced by the unequal heating of the Earth's surface. If you take a look at the image that I have on my screen, it is very similar to the image on page 104 of the Pearson textbook. The yellow bars are indicating the length of the sun's rays. You'll notice by the equator, the center of the Earth, is where the bars are the shortest because the equator is closer to the sun, right, making it warmer. If you look, the North and the South Pole, the rays are longer because the North and South Pole is farther away from the sun, making these colder regions. If you look at the length of all the sun's rays, you can see that there is an unequal heating of the Earth's surface, causing winds to be produced. There are two types of winds that can be produced because of the unequal heating of the Earth's surface: local winds and global winds. Today we're strictly going to focus on two types of local winds that can be produced. Local winds can be defined as winds that blow over short distances. Again, they are produced because of the unequal heating of the Earth's surface within a small area. There are two types of local winds that can be produced: a sea breeze as well as a land breeze. Take a look at this diagram I've included on my PowerPoint presentation. A and B illustrate a sea breeze as well as a land breeze that are being generated. Letter A illustrates a sea breeze. During the daytime, land warms up faster than water. The air over the land gets warmer and rises, creating a warm pressure or low pressure area. When this air gets over the water and higher in the atmosphere, it's going to start to become cooler. Cooler air sinks, creating a high pressure area. When this cool air, comes over land, it will push the warm air up. When it pushes that warm air up, it will cause a breeze to occur over the land. And as you can see, it is a movement of high pressure to low pressure. We call this a sea breeze because if you remember from an earlier unit, winds are named after where they come from. So in this case, the breeze is coming from the sea and going to land. It is a sea breeze. These sea breezes will continue as the convection current of hot air rises. Then it will sink once it gets over water. All right. As it continues on, we will have multiple sea breezes be produced throughout the day because of the rotating convection current. Now let's take a look at letter B. This is a land breeze. You will notice the convection current switches. At nighttime, when the land cools down faster than water, the warm air is going to rise over the water. All right. As it rises, gets higher in the atmosphere, and gets over land, the air is going to cool down and sink. All right. This cool air will force itself over the warm water, pushing the warm air up again, and it will cause a breeze to go out to sea. This is called a land breeze. All right. Again, it's where the air comes from the land and pushes out to sea. Multiple land breezes will be produced because the convection current continues throughout the night. Now let's take a look at these land and sea breezes in real time. So let's take a look at this interactive. What you'll see on this interactive is the time as well as the temperature of the land and the ocean. You'll notice right now it's a sea breeze. The land is warmer than the ocean. All right, the sun is out, so the warm air is coming off of the land. All right, when it gets over the water, it will start to cool down because it's cooler over the ocean. When that cold air gets over land, it will push the warm air up, and when it pushes that warm air up, a breeze will be produced because A wind is produced from a high pressure area, which is also cold air, to a low pressure area where it is warm air. So let's continue on and see what happens. As the day comes to an end and night comes, you will see that a switch is going to occur. A land breeze is produced. At this point, land becomes colder. The ocean temperature stays the same as it was throughout the day. So the warm air is going to be produced over the ocean. The warm air rises because it's less dense. As that air gets over the land where it's colder, it's going to start to get colder and sink. All right. When that cold sinking air gets back over the ocean again through that convection current where it's constantly rotating in a circle, that high pressure is going to cause a breeze to be produced when it meets the low pressure, the warm air. All right. And a breeze will be produced from land going out to sea. All right. Let's continue on and watch how this land breeze gets continued and how it will change into a sea breeze as the day continues. So please be ready to come to tomorrow's class, ready to discuss land as well as sea breezes. And if you have any uncertainties about this information, please be ready to discuss with your partner as well as myself. I'll see you tomorrow.